final problem with average value here deals with a trigonometric function, specifically sine of x. So they ask us to find the average value of sine x from 0 to pi over 2. I'm going to label 0 as a, the starting point, pi over 2 as b, the ending point. So when I plug into this formula, it becomes 1 over b pi over 2 minus a0, the integral from a0 to b pi over 2 of f of x sine x dx. When I go to do the first step, which is simplifying the outside, 1 is being divided by a fraction. When you divide by a fraction, you flip it and multiply. So it's 1 over pi over 2, which becomes 2 over pi. On the inside, I need to say something has the derivative of positive sine x. If I'm not sure on the signs here, it's best to look back at the two original derivatives we learned. We learned that if f of x equals sine x, the derivative would be positive cosine. We learned that if f of x equals positive cosine x, the derivative would be negative sine. Basically, I can take either of these two formulas and multiply it by a negative 1. So if I originally had f of x equals negative sine x, its derivative f prime of x would have been negative cosine x. If my original f of x was negative cosine x, its derivative f prime of x would have been positive sine x. So really, I look at these four possible ways that it can come and I say, what do I have currently as what's under my integral sign or the derivative? I currently have a positive sine x as my derivative. So that points me to this version. If I have a positive sine x as the derivative, then a negative cosine x is the integral. So this becomes negative cosine x being evaluated from 0 to pi over 2. When I now evaluate it, I first take the value when I plug in a 0. When I plug in a pi over 2. If I put into my calculator, making sure that it's in radian mode, negative cosine of pi over 2, it'll tell me 0. If I then try it for b, and I put in negative cosine of 0, it'll tell me negative 1. We're always doing what you get from putting a in minus what you get from putting b in. So it becomes 0 minus a negative 1 or a positive 1. When I take 2 over pi and I multiply it by a positive 1, I get my final answer of 2 over pi. That 2 over pi probably will be accepted by Cengage, but if you need it as a 4-digit number, 2 divided by second pi gives me 0.6366. So the good news is that we've now found the correct value for the average value of sine x from 0 to pi over 2. The bad news is it's a little tougher to find everywhere in the interval where it equals its average. If we did the same thing that we did for question 1 and just set it equal to each other, we'd be setting 2 over pi equals sine x. And the way that we could then find an answer is we can do sine to the negative 1 of pi over 2. Sine to the negative 1 would cancel out these signs, and that would give us what our x is. So if I put into my calculator, second sine, which gives me sine to the negative 1, parentheses 2 divided by pi, it tells me that I want the answer of x equals 0.6901. Here's the problem. Because sine curves and cosine curves have periods that repeat and basically go on for infinity, this is only going to ever give me the first answer. If there's additional answers, I won't really be able to find them. I could show you ways of manipulating the curve in order to find it, and I could show you a lot of pre-calculus stuff that would make this make a little more sense, but honestly it'll be much easier if you just use your graphing feature in your calculator, set it up, and find where the curve intersects the line that you're looking for. So let me show you what that would look like on this problem. First thing I do is I hit my y equals key at the top left of my screen. After I hit y equals, I'm going to clear out anything that's already there, and I'm going to put in sine x. Make sure you're pressing the sine button. Make sure you're pressing the x that's right below mode that says x t theta n. Once I have it in as sine x, I now want to set my window. So I'm going to press the window button. It starts out x min -10, x max 10. But we know we just care about x's between 0 and pi over 2. So I'm going to set x min to 0. I'm going to set x max to pi divided by 2. The x scale is set at 1. It's fine to leave it that way. When it tells me what my y min and y max are, I'm going to set them to -2 and 2, just so it shows up nicely on the screen. But we know that sine can only go between -1 and 1. If I have all that window set correctly and I press the graph button, it's going to show me the part of the sine curve that I'm concerned with. So on my graph, I see this curve looking like this, where it hasn't come down yet. It's only going up. If I now want to find where does it equal 2 over pi or 0.6366, I can go back to my y equals. y1 was sine x, and I can now put in a y2. Specifically, what I'm going to put in for y2 is 0.6366. 0.6366. Now when I graph, there's a line that comes across my curve. I want to find where the line meets the curve. To do that, I press second, calculate. So I'm pressing the button second, then I'm pressing along the top, trace, or calc. From there, I'm selecting option number 5, intersect. After selecting option number 5, intersect, it'll ask me first curve, second curve, guess. If you literally just press enter, 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 as long as you only have y1 and y2 on, it'll absolutely work. So I just press enter, enter, enter at this point. It tells me intersection, x equals 0.69008145, and y equals 0.6366. So here's the x value I wanted, which you can see rounded to 4 decimal places, is the same x value that I found mathematically. In this case, the two methods weren't very different. But look what would happen if, for instance, we went from 0 to pi instead of 0 to pi over 2. This curve would continue coming down, this line would continue going across, and there'd be a second point of intersection that I need to worry about. If I'm doing it graphically in my calculator, I can find that intersection just by guessing closer to the second point of intersection the next time, and I can separate the two possibilities. If I'm trying to do it mathematically, like here, it's only going to give me the one answer. So my recommendation is that you try and do it graphically to figure out both answers for what, spoiler alert, is going to be a 2-answer question when you do it in the homework.